Let's go over the topics of reactivity series and redox reactions according to the Edexcel IGCSE specification. The reactivity series is an arrangement of the metals according to their reactivity. The reactivity series arrange metals in order of their reactivity towards other substances, where the most reactive metals will be at the top of the series, and as you go down, the reactivity will decrease. Reactivity of metals is determined by how easily they can lose electrons to give positively charged ions. In the reactivity series, you can see that there are two non-metals included in the series. These are carbon and hydrogen. The presence of carbon and hydrogen are quite important because metals which are below carbon in the reactivity series are less reactive than carbon. And they can be extracted from their ores by reaction with carbon. And the topic of extraction of metals from their ores will be covered in a different video. And the presence of the hydrogen is quite important as well, because metals which are above hydrogen in the reactivity series are more reactive than hydrogens, means that they can actually react with acids to give the metal salts and they will give hydrogen. So that determines the reactivity of the metals towards carbon with the metal oxides towards carbon, and for the reactivity of the metals toward the acids. You can memorize the reactivity series either using the mnemonic, the following mnemonic, or by using a different method depending on your understanding. So let's go over these two and see which one works for you. The first thing that you need to know is what is the different metals and what is the orders of the different metals. We have potassium, sodium, lithium, calcium, magnesium, aluminium. Then we have the carbon, and then zinc, iron, and then we have hydrogen, then copper, silver, and gold. The following mnemonic can help you memorize the order of the metals in the reactivity series. It says, please stop lying, calling me a careless zebra. I heard copper saved gold. So if you can memorize this mnemonic, that can help you memorize the order of the metals in the reactivity series, including the where you can find the carbon and the hydrogen. There's another way where you can memorize the reactivity series, and this way will depend on your understanding or of how the metals react. When we look at the periodic table, metals are the ones that we can see in group 1, group 2, group 3, and also we have the transition metals. We know that metals, which are group 1, 2, and 3, will be more reactive than the transition metals. So metals which comes from these groups will be above the transition metals in the reactivity series. And then group 1 metals are more reactive than group 2, which are more reactive than group 3 metals. Also, as you learned from the group 1 metals, the alkali metals, that reactivity of metals increases as you go down the group. So putting all of that in mind, keeping all of that in mind, you can now look at the following. The first three elements come from group 1 metals or group 1 elements. And as you can see, we start off with potassium, then sodium, then lithium. So we go from down to the top of the group 1 metals. And then the following two will come from group 2. Again, we're going to start from the down going up. So calcium first and then magnesium. And the following metal will be from group 3, which is aluminium. And following group 1, 2, and 3, we're going to have the carbon. Then we're going to start to see the transition metals. So following the carbon, there is zinc, and then iron, and then hydrogen. To memorize that, remember that following the carbon, there will be that elements which start with the last letter in the alphabet. So zinc first, and then iron. And following the hydrogen, we're going to have these metals, which are copper, silver, and gold, these ones which we use in jewelry. Or you can simply remember that copper saved gold. So copper, silver, and then gold is the last one in the reactivity series. Now let's have a look at the reaction of metals. Metals can react with acids. We said that the metals which are above the hydrogen in the reactivity series, they can react with acids. They can react with cold dilute acids. And the type of acid that we're talking about are things like hydrogen chloride, sulfuric acid, or nitric acid. The reaction of metals with acid will give you salt of the metal and hydrogen. The speed of the reaction is indicated by the rate at which the bubbles of the hydrogens are given off. So in this reaction, you're going to see some fizzing due to the bubbling off of the hydrogen or due to the production of the hydrogen. So very reactive metals, the one at the top of the reactivity series like potassium, sodium, lithium, and calcium can react explosively or very vigorous reaction. Like potassium here, you can see some fire because the reaction is very vigorous. And then as we go down in the reactivity series, less reactive metals, but they are still above the hydrogen in the reactivity series, like magnesium, zinc, and iron, they react less violently. As you can see, as we go here from left to right, the reactivity of the metal decreases and the bubbling of the hydrogen decrease as well. Metals below hydrogen in the reactivity series, like copper, will not react with dilute cold acids. However, if you use concentrated acids or if we heat it, they might react with the acid as well. When you write the equation for the reaction of metals with acid, don't forget the state symbol. So, for example, if we react magnesium, magnesium is going to be a metal, so it's going to be solid. So don't forget the letter S for solid. And then when reacted with dilute acid, like hydrochloric acid, we have to put it as aqueous because this is dilute acid. And then we're going to end up with the salt, which is magnesium chloride. This is going to be soluble, so it's going to be aqueous. And then plus hydrogen, which is given off as a gas. Another example, if we react magnesium as a salt with sulfuric acid as aqueous, going to give you magnesium sulfate aqueous and hydrogen as a gas. Or even magnesium with nitric acid aqueous will give you magnesium nitrate aqueous and hydrogen gas. We can test for the hydrogen gas that is given off by using the burning splint test, where the hydrogen will give a squeaky pop sound. Metals also react with water. Some metals react with water to give metal hydroxides and hydrogen. The word equation for that is that water plus metal will give you metal hydroxide plus hydrogen. The speed of the reaction is indicated by the rate at which the bubbles of hydrogens are given off, the same way as we've seen with reaction with acids. The more reactive the metal, the faster the reaction. Usually, very reactive metals like potassium, sodium, lithium, and calcium can react with cold water to give metal hydroxide and hydrogen. However, the less reactive ones, which are magnesium, zinc, and iron, will not react with cold water, but they can react with steam. So when they react with steam, they still gonna give metal, but not metal hydroxide. They will give metal oxides and hydrogens. So copper is so unreactive that it will not even react with steam. So remember that reaction of the less reactive metal with the steam will give metal oxides and hydrogen, but the more reactive ones will give metal hydroxides and hydrogen. When you write the equation again, remember to put the state symbol. So calcium, which is one of the reactive metals, react with water as a liquid, not with the steam here, to give you calcium hydroxide as aqueous plus hydrogen as a gas. And don't forget that we can again test for the hydrogen gas by the squeaky pop sound with the burning splint. Another reaction is that more reactive metals displace the less reactive ones from their salts. We can look at the reactivity series. And the more reactive metals, the ones that are above in the reactivity series, can react more strongly than less reactive ones. They are more reactive. They can lose the electron easily. And they can displace the less reactive metals or the metals which are below them from their oxides or from their salts. For example, if we look at aluminium, aluminium is above iron in the reactivity series. So aluminium is more reactive than iron. Aluminium as a metal can react with the iron oxide and displace the iron from its oxide. Aluminium can make a stronger bond with the oxide, so it can displace the iron. That means that aluminium, when it reacts with iron oxide, will give you iron plus aluminium oxide. And this is the equation that is balanced equation for the reaction between aluminum and iron oxide to give you aluminum oxide and iron. The more reactive metals, the faster the reaction. So if we want to judge, or if we have a mystery element and we want to know where its place in the reactivity series, we can judge that based on how fast the reaction of different metals with a certain salt and how it can displace the other metal from its salt. Usually we can see that by the temperature a change in the reaction. So the more the temperature change, the more reactive the metal. For example, we have a reaction between calcium, and we can see that calcium is above copper in the reactivity series. So calcium can react with copper sulfate as a copper salt. So it can displace the copper from its salt. That will give calcium sulfate and will give copper. So it displaced the copper. Also, iron is still above copper in their activity series, so it can react with copper sulfate to give you iron sulfate and copper. However, the calcium is more reactive than iron, so the rate of the reaction of calcium with copper sulfate will be faster, and the change in the temperature for this reaction will be more than the change in the temperature for the reaction between copper sulfate and iron. Remember that if you have a metal which is less reactive, it cannot displace the more reactive metal from its salt. For example, if you react copper with magnesium chloride or magnesium sulfate or magnesium oxide, there will be no reaction because copper cannot displace the magnesium, because magnesium is above copper in the reactivity series and it's more reactive. That will take us to the second topic, which is related to these reactions, which is the oxidation and reduction. This is called redox reactions. Gaining the redox reaction or oxidation and reduction can be defined in terms of gaining and losing of oxygen. So gaining of oxygen will give you oxidation, and losing, for example, if we react magnesium, heat magnesium in air, magnesium will react with oxygen, so it's going to gain oxygen, so it's oxidized. This is called oxidation. And then loss of oxygen is known as reduction. So this is a reduction reaction. An example of reduction and loss of oxygen: if you react copper oxide with carbon, that will give you copper and carbon dioxide. You can see that the copper here lost oxygen to give you the copper metal. So copper ion has been reduced. So this is called reduction. Redox reaction usually refers to any type of reaction that has oxidation and reduction. When one atom is oxidized in a reaction, there must be another atom that has been reduced in the same reaction. So usually oxidation and reduction, or always oxidation and reduction, will take place in the same reaction. This is called redox reaction because it has oxidation and reduction at the same time. Redox can be defined in terms of gaining and losing of oxygen, as we have seen, but more wider definition is the loss and gain of electron. And remember this term, oil rig. Oxidation is loss of electron, and reduction is gain of electrons. So oil rig. So don't forget that to memorize which one is oxidation, which one is reduction. And as we are talking about oxidation and reduction, we need to know that there is something called oxidizing agent and reducing agent. The substance that is oxidized in the reaction is called reducing agent because it's going to reduce the other substance. And the substance that is reduced is going to be called the oxidizing agent because it's going to oxidize the other substance. So let's have a look at different redox reaction from the ones that we just learned and learn how to write the redox equation. So the first reaction is the metal displacement reactions. So we have the reaction between iron and copper sulfate to give you iron sulfate and copper. Here, as we can see, iron was oxidized because iron here was an iron metal. Iron metal doesn't gain or lose electron. It has zero charge. It's neutral. And then it gave the iron here in this compound, iron sulfate, and iron here has 2 plus charge, meaning the iron lost 2 electrons to give you Fe2 plus ion. And we can write the half ionic equation for that. The half ionic equation is this equation that will show the movement of the electron. So the iron will lose 2 electrons to give you iron 2 plus. Don't forget to write the electrons as well on the right hand side because it lost the electrons. This is oxidation now because oxidation is loss of electrons. So half ionic equation is this equation which shows the oxidation separately from the reduction. Iron here will be the reducing agent because it was oxidized because it lost electrons. On the other hand, we have copper. Copper here was an ion. Copper was copper 2 plus, and it gained 2 electrons to give you the copper metal, which is the copper which doesn't have any charge. It's just a copper metal. It's neutral. So copper gained 2 electrons to give the copper ion atom. And we can write the ionic equation for this reduction where copper 2 plus gained 2 electrons to give you the copper. This is called reduction. Now the copper ion is the oxidizing agent because the copper ion is the one that was reduced. So it's called the oxidizing agent. Iron was oxidized by the copper 2 plus or the copper ion in their salts, and the copper 2 plus was reduced by the iron atoms. And now we can write the ionic equation. When we write the ionic equation, we are going to combine the two half equations together and making sure that the number of electrons on both sides of the two reactions are the same or of the half equations are the same. Here we have 2 electrons on the right-hand side and 2 electrons on the left-hand side, which are going to cancel each other out. And then we're going to write the ionic equation where iron plus copper 2 plus will give you iron 2 plus plus copper. This is the ionic equation. It's different from the equation we wrote here. As you can see, the sulfate was not included in the ionic equation because the sulfate was not oxidized or reduced. So it doesn't need to be included in the ionic equation. Or simply, the sulfate did not take part in the reaction. We call the sulfate here the spectator ion, and we do not include it in the ionic equation. Another example of a redox reaction from what we've learned is the reaction of metals with acids. So we have iron with hydrogen chloride, will give you iron chloride and hydrogen. So iron here was oxidized because iron lost 2 electrons to give you iron 2 plus. And hydrogen was reduced because hydrogen ion from the hydrogen chloride, hydrogen here was hydrogen plus, it gained electron to give you the hydrogen atom. Now, the iron was oxidized by the hydrogen of the acid, while the hydrogen was reduced by the iron atom. So let's write the half ionic equation for this. Iron will give you iron 2 plus plus 2 electrons. This is oxidation. Iron here is the reducing agent. And then we have 2 of the hydrogen plus 2 electrons will give you H2, which is the metal, which is the element hydrogen hydrogen. Of course, the element hydrogen will not exist as monoatomic. It will always exist as diatomic. So we have to add 2 of the hydrogen plus 2 electrons that give you the H2. This is reduction because hydrogen ions gained 2 electrons. And now let's write the ionic equation by combining these two half equations. So iron plus 2 hydrogen plus will give you iron 2 plus and hydrogen 2, or the hydrogen as an element. The chloride here was not included because this is